Hey guys, welcome back. Today we're going to walk through a sanitary sewer conceptual layout, and in this process we're going to give you kind of an overview of some of the requirements for sanitary sewer. But in the beginning part of a project we really just want to lay out a very simple sewer system so that we can figure out some rough inverts, and then when we start laying out our storm we can identify potential problems on the front end. So let's walk through this process and see how to do a conceptual sanitary sewer layout. Let's learn. Today we're going to walk you through the conceptual sewer layout for the Probasco Street residential project. This is going to be a pretty simple process. You can see on the screen we have the Word document. There's really just two main things that you need to do, which is one, drop in some structure locations, and then two, connect them with some polylines. We do also need to think about inverts and the depths of pipes. This is not really imperative for this phase of the project, but we want to provide more information and give you everything to think about in the beginning. There's also some general guidelines, types of pipes, slopes, and things like that. So let's look at this project. We have here our existing sewer line. This line is about 6-7 feet deep here. We don't have the exact inverts because the manhole was buried, but generally we're going to connect here, and then we want to run on residential stuff. We want to run the sewers up the center lines of the streets, and so it might be something like that, and then on this street something like that. So this sewer would flow this way and then flow that way and connect, and then this would flow this way and connect. So in this Word document, one of the things that we need to do is look at the tie-in elevations, and we need to check the total fall. The required fall should be pipe cover at the upstream structure, and then the length of the trunk line times 1%. So we're going to want our invert to be about 6 feet down. So let's say we start up here at 898 and we subtract 6 feet for the invert of the pipe. That's going to be 892, and then the length of this pipe here is about 1600 feet. So 1600 feet at 1% is 16 feet. So 892 minus 16 is going to be 876. So our fall needs to take us down to 876. Well, this elevation is 824, which is about 50 feet lower. So we know we have plenty of fall. And we just want to do that quick check in the beginning, because sometimes there's not enough fall, and it may be that we have to raise these grades up higher just so that we can get the sewer at a minimum slope and get everything to flow. So it's always good to just do that quick check in the beginning, but we have plenty of fall. So let's take this manhole and we're going to drop it in right on top of this. We're going to make a doghouse manhole, and let's grab a new piece of text. And let's put sanitary sewer manhole or junction box doghouse, top, invert in, invert existing, let's do it like that. So the existing is going to be about 7 feet deep. This was 724, so I think this is going to be about 817. I should have said 824. 824 minus 7 is 817. And then the invert going in, let's leave ourselves a little bit of room. Anytime you're tying into something, it's good to leave yourself margin, so that if you get there and maybe the existing line is a little bit different than what the surveyor had said, then everything still works. If we put the invert going in at 817.1 and then it turned out that the existing pipe was 817.5, well, now we have to redesign the entire line because we didn't have enough margin. So it's always good to leave some margin on the tie-in. So a quick layout, and we have a basic structure already. So let's start thinking about this a little bit more. So we go from 898 up to 900, so that's going up 2 feet and then back down 2 feet. And that's fine. It just means that there's going to be a little bit more cover on the pipe here, but that's totally fine. It's much more common for sewer pipes to have a lot of cover, be 15, 18 feet deep than it is for a storm line. It's very uncommon for a storm pipe to be 20 feet deep, but it's totally normal for a sewer. So then this is going 8, 98, 94, 90, 80, 70, 60, 50, 40, 30. So that's pretty much just a nice run all the way down. And then let's look at this one. 900, 890, 80, 70, 70, goes up to 78, and then back, and then it kind of fluctuates around 70. So if we're already 16 or 6 feet deep here, and then we go even deeper and add another 8, we might be 14, 18 feet deep there, but we'd rather keep it cheap. So one solution that we could do is these pads, these houses are going to sit a little bit lower, and we have a 70 there. I'm just going to take that, we'll go down to this low point here, straddle that property line, go down to the 70, and then we'll just run across the back of these lots and just connect back like that. And that'll keep our trench depth less. So the maybe two main constraints that you want to think about when you're doing this is your pipe cover and the slope of your pipe. For a main, you can easily go down to a half percent, but it's nice to keep it at 1% for a preliminary layout. And I just want to show you an example. So like, let's say our ground, does something like this, and we need to drop in a pipe. We start 6 feet deep. Well, if we just go 1%, we're going to end up there, and that's not going to work because the pipe's not underground. So if we keep in mind the two main constraints of the minimum slope of 1% and the minimum cover, in this area of the ground, we're going to kind of match the depth or match the slope of the proposed ground so that we keep our trench depth, the minimum trench depth. Well, in this area, we're going to want to go down at 1%, and so now the 1% criteria would control. And then again, if we went down 1%, we would come out of the ground. So now we're going to go back to keeping our minimum slope. So if you keep those two criteria in mind, sometimes you're going to follow the topography of your proposed grade, and then sometime you're just going to be going at the 1%. And the goal again is keep your pipe trench as shallow as possible to keep the cost down, but while still meeting our minimum cover requirements, which for PVC pipe, you want to generally just keep 5 feet of cover, so your invert would be 6 feet down. So let's start putting in some of these structures here. So we're going to do one there. Let's do one maybe here. We can move these around. I'm going to drop this right on that blue line, which is the center line. I'm going to do one at the intersection of this center line. And one at this intersection. One down here. And that's an offset cul-de-sac. And then one here, this cul-de-sac is right in the middle. And when we come over here, I really want this pipe to be centered on that property line so that I can put a nice easement across there. So I'm going to drop that one right on top of that. And then one more over here. Okay, so we've dropped in some structures, which was the first part of this document, drawing some structures. Generally, we want to keep them about 300 foot max spacing. You can go up to 400 depending on the jurisdiction. If it's a more urban area, they're probably going to have, or a more restrictive city, they're probably going to have a 300 foot max distance spacing. But if it's a rural place, they'll probably let you go up to 400. So, but generally keep it in that range. And this is a pretty rural setting, so we're going to kind of use the 400 foot guideline for that. Okay, so let's connect them back with polylines again. And we always want to start from the low connection point, tie-in location, moving uphill, moving upstream, because that's the way the contractor will build it. And I put that in the wrong place. Actually, we don't even need one there. I shouldn't have put that in there. So that's one run, and then the other run let's get rid of that. And then the other run will start from the low end and then work our way back up. Okay. When you're laying these things out, I just said you want to work from downstream to upstream. However, when you're putting in inverts in, you generally want to start with the upstream, because the upstream is going to be one of your constraints. You're going to have two constraints. You have a constraint where you're tying in and you can't change that, but you also have a constraint at the most upstream elevation based on the cover of your pipe, and you can choose a different elevation here. Like we could, right now this cul-de-sac is at 900, but we could make that 890 if we wanted, or we could make it at 910. You know, that may not be a good decision with regard to earthwork, but we can change it. So this is a chosen constraint, and this is a natural constraint. And the reason we want to start in the uphill side is because we want to start with our minimum pipe cover to keep our trench shallow, and then work our way down, just keeping it as shallow as we can. So let's grab a piece of text here, and we just want to rough in some numbers. And so this is going to be sanitary sewer junction box number something, top, invert in, invert out. And let's put this on the same layer as this other one. Let's make these a little bit bigger. So we have a junction box, a top, an invert in and out. We'll copy this to these other locations. And then this last one, it doesn't have an invert in, so we really can just delete this piece. And same thing with this one here. Okay, so if this manhole is going to be about 900, we want 5 feet of cover. Let's just go down 6 feet to the invert. So the top is 900 feet, and the invert out is going to be 894 feet. If we're putting this manhole in, let's make this one JB number 1. This one can be 2. This one can be 3. And we've kind of set this up so this is the main line. So I'm going to make this one 4. Well, maybe we should change that. So we have more structures this way. We have 3 this way, and we only have 2 that way. So we could say this is 4, 5, and 6. I'm just going to leave it the way we've already started. So that's 4, and this one is 5. And so this run comes off the number 3. So this one is going to be 3.1, 3.2, and 3.3. Okay, so let's work our way down at 1%. Just going to do a quick measurement, and that distance is about 400 feet. So 1% of 400 is 4 feet. So I want this to slope down from 894 to 890. Well, 890 is about 20 feet higher than the grade here. So we're going to want to go down to at least 6 feet below this, this 69. So 69 minus 6 is going to be 63. And so we're going to come in at 963. And 969. And then we're going to go out 1/10 down, 962.9. Okay, and then to get from here to there is 114. Let's just say we want to round up to 120 just so we're using tenths. So so let's just say 114. 114 times 1%. 114 times 1% is 1.14. We'll round up to 1.2. That might be an easier way to say it. So 1.2 feet of fall. So it comes out at 62.9. We'll go down 1.2. So that's going to be 61.7. So the in here is 961.7. And then out is going to be 1/10 down, 961.6. And the top here, we have this sitting by that 870 contour. So let's make that 870. And I don't know why I keep saying 9. This really should be 8 is the hundreds digit. 8, 8, 8. And that one was correct. Okay. Now let's measure the length on this one. And that is, just say we'll round up to 390, which is going to be 3.9 feet. You can see this grade, is pretty flat the whole way. We're close to 70. That's close to 70. So in this instance, the 1% is going to control. So 861.6 minus the 3.9 feet of fall is 857.7. So this is going to come in at 857.7 and go out at 857.6. And we're going to have 2 inverts going in and 1 going out. So let's add this in. The main trunk line is coming from the west. So we'll put the west first. And then we'll put, actually that's not east, that's south. And then we'll put the south one second. So that's west. For now, we'll just leave that at the same, but we'll check that later. And then the top was about 868. Okay. Clean these up a little bit. Now here I can see the grade falls a lot. So let's just say this is going to be 839. So I know the 1% is not going to work here. We're going to have to use our cover constraint. So 839 minus 6 is 833. So the top is 839, 833.0, and going out 832.9. And we can add tenths in there. We will need it eventually. And then if we're coming in at 818, really, that's already done. It's going in, coming out at basically 33, going in at 18. And so that is about 15 feet of fall. and the length here is probably about 400 feet, smidge over 400, so we probably want to drop another structure in there, but 15 feet divided by 410 is 3.5%, so that's a fine slope. For now, since we're just doing a conceptual storm layout, we may tweak this. Hopefully maybe we add 2 manholes. I think it's fine for now, but when we get to construction documents, we may want to change that and add another structure. Let's see how long this one is here. This one, well, that's 400. Why don't we just go ahead and add another structure? So I'm going to go in here, add a vertex. I'm just going to pick a place, maybe there. Maybe we move this guy up this way. That still might be a little bit close to that pond. And now we can probably move this down this way a little bit. Let's try something like that. Okay, so this one is going to be 2. That one is going to be 3. That's going to be about 46. So let's say 846 minus 6 is 840, and that's going to be 839.9. This one is going to be about 830 minus 6 is 824 and 23.9. And so from 24 to 18 is 6 feet, and 6 feet divided by 250 is 2%, so that's fine. All right, so JB3, now we're gonna need to update all these. This one's gonna be 4, 5, 6, and 4.1, 4.2, and 4.3. Okay, so let's start back on this side. If that's 98, let's just say this top is at 98. Again, this is conceptual, so it doesn't need to be too exact. The goal is, let's just get a rough layout in there with some inverts so that when we lay out our storm, we can identify any conflicts and have an idea of what we want to do. The goal is not to have a finished product of a sewer design. We just want to get it in there very rough and have it working. So the invert out, we're going down 6 feet there, 898, and this one, the grade is about even, so we're going to be going with a deeper trench, but we're going to go at 1%. So from there to there is, we'll round that up to 360, so 3.6. So 92 minus 3.6 is going to be 8988.4. So the invert in is 888.4, and then our out is going to be 888.3. And the top was going to be about 898. And this is the next structure. From there to there that's 426, so we probably want to add another manhole in here. trying to think where we want to put this manhole. We could do a little line coming down this way. So all of these houses can easily connect to this. This house can easily connect to there. This house can easily connect to here. But we are kind of leaving these two guys hanging. I almost wonder if we should just drop another structure in this way and come in between these two lots for these two guys to connect. And that would be shorter than going this way. But we do also probably need something. I don't think we want to run one this way, so I think we should just put this kind of right in the middle. Or here's another thing to think about, right? This grade is dropping pretty fast, and then here it flattens out. So maybe we put it over here just on this side of that flat area. So let's move this guy over here somewhere. Let's add a vertex, put that there, and then this one is going to be, let's just say 872. 872, and go down 6 feet, so that's going to be 66 and 65.9. Then let's make that 6 and 7. So you can see this thing has, as we got a little bit more into the details, it's changed a little bit since the very first time we dropped in some property lines. And then we think we wanted to add one right here, right? So let's grab this. Just move that down. We'll make an extension there. We'll drop this right on top of that, and then we'll copy this one, and we'll put it right on top of those two lines. So I'll do the apparent intersection, add vertex, move that to that point, and these lines, maybe we feel like the S's are too big. If you want, you can change the line type scale to 0.7, and I do that a lot. I think that looks a little bit better. Okay, so let's figure this new manhole out. We'll start from here out 60. Actually, let's start here. It might be easier. So the invert from the south is 57.7, and we need to go 200 feet. So we're going to come in 2 feet above that. So we're going to that's going to be going out of this structure at 59.6. So this one's going to be 4.3, and it's coming out at 59.6. Is that correct? 57.6, yep. And so the N is going to be a tenth higher, 59.7. And then the top is still at about 870. And then this one, if we go up at 1%, it's going to be pretty close to 60, 61, but that's really deep here. So let's start at the top again, and that's 78, 878, go down 6 feet, 872, and then that's going to be 871.9. We just want to check that this seems 10 feet deep. Does it need to be that deep? So we were at 69. We were 6 feet there. We went down to 1%. 62.9 to 61. So that's 9 feet deep. And then we go from 61.6, and that's 180 feet, which is 1.8. So we subtract 1.8 from this, and that's going to be 60.6, 59.8, 59.6. So yeah, that is the minimum. Okay, so we have 4. This should be 4.1. This one is going to be 4.1.1 because it's an offshoot from that guy. And that's 4.2. Sorry, 4.1, 4.2, 4.3, and 4.4. Okay, and so I think that's it. 1, 2, 3, 4, 5, 6, 7. So that's generally it. We could throw an easement on here. So let's do that real quick. We'll offset 5 feet on either side. Turn these into easements. And that should be a proposed easement. So let's go up here to CA easement. Once we get to the right-of-way line, it doesn't need to exist anymore. What are those 2 lines? Oh, that's the water line. Okay, so this is the right-of-way line right here. So let's trim that. These we can just delete. So we have an easement that goes that way, and it stops once it gets to the right-of-way line. And easements describe an area of land. So this area needs to be closed in. And then let's trim this off over here. PJJ to connect that. Let's connect these. PJJ. And I think we just need to close this off over here. And make that 0.5 wide. So there's our easement. And so that's it. Conceptual sewer layout. We worked from our natural constraint, picked a few chosen constraints, and then worked back using the 2 main constraints for the layout as a minimum pipe cover, and then the minimum slope of 1%. And remember, there's different types of pipes with different pipe cover requirements. So we use 6, but we could have a ductile iron pipe and